This is on the proportional, lengths of proportion, what did it say?
Length.
Thank you, proportional lengths, it says like 7.4, it's from another school that I used. Okay, so if we look at number 5,
It's not showing.
oh, sorry, I gotta reset this thanks. All right, so on number 5, you've got 3 parallel lines, and if you remember, when you have these parallel lines, they cut these side pieces into pieces that are proportional. So I've got 9 and 3, and I've got 12 is this piece, and then this whole piece here, I'm going to use a color to, let's see, from here to here is x. So if I'm trying to solve for x and I want to make a proportion, what I could do is, since I'm going to be looking at these little pieces separately, maybe this little piece down here that I would need kind of separated out, wouldn't that be x minus 12? Because the whole thing is x, and the top part is 12. So I could label this x minus 12, and now I can make my proportions because I've got all these parallel lines here. That means I don't have to try to do anything weird here. I can just go 9 matches up with 12 the way that 3 matches up with x minus 12.
So
okay.
9 doesn't match up to 3.
No, the whole thing is.
So it's not 9 to 3.
You could put 9 over 3 is 12 over x minus 12. You can do it. Yeah, there's a couple of different ways you can set them up. I go across just to make sure I'm, putting pieces that correspond kind of together. But you could do it that way too. You'll come out with the same proportion. If you look, when you cross multiply, you'll still get 3 times 12 is 36. And then you'll have 9 times x minus 12. Just be sure to put that x minus 12 in parentheses. So if I distribute here, I get what? 9x minus, I think that's a 108. Okay? So if I'm going to solve for x, I'm going to first move that 108 to the other side by adding it. And I get 9x is equal to 144. And if I divide both sides by 9, I'll get x. And I don't want to think. I'm going to get my trusty calculator out. 16. X equals 16. Okay, so let's see, is it number 10 on the back side, right? Okay, just making sure. Okay, so we've got this triangle drawn, and it's got parallel lines marked here and here. So we know anytime we've got a triangle or a figure that has these parallel lines in it, all these little pieces are proportional to each other, okay? So this one just had lots of x's in it. This was 4x plus 1 here. This was 10x minus 4. This was 5x minus 1. And this was 2x plus 1. It might be easier if you kind of turned your paper this way. It might be a little easier just visually to match this up. I'm going to set mine up the way that Elena did this time just to show you that you can, okay, the way she was talking about it. I could go across the triangle. I could go across the figure, or I could do 4x plus 1 goes with 10x minus 4 the way that 2x plus 1 goes to 5x minus 1, okay? So, that's another way to set them up, and that's the way she's been setting hers up, and that's great. That works too. So now we got a big mess, because when we cross multiply, we get 4x plus 1 times 5x minus 1 equals 10x minus 4 times 2x plus 1. So we got a lot of distributing. What we basically need to do is, to simplify this mess, is multiply it all out on both sides, move all the terms over to one side so we can solve. Because probably it's going to be a square type equation, and we're going to need it set equal to 0. Okay, so here we go. 4x times 5x is 20x squared. 4x times negative 1 is negative 4x. But then I've got 1 times 5x, so that's positive 5x. And 1 times negative 1 is negative 1. Now let's clean that side up. That's 20x squared plus x minus 1. Let's go do the same thing to the other side, and we'll move all the terms and try to figure this thing out. It actually ends up looking like it might work out where it's not nearly as bad as we might think. 10x times 2x is 20x squared. Yep, that's a good sign. 10x times 1 is 10x. Negative 4 times 2x is negative 8x. And negative 4 times 1 is negative 4. And let's see, that cleans up to 20x squared. 11x minus 8x is 3x. Huh?
It's 10x.
Oh, did I misread my own writing? Yeah, it is 10x. So 10x minus 8x is, thank you for catching that, 2x, right? Minus 4. So let's say I decided to move it all to the left side. What's going to happen with that 20x squared when I subtract it? It goes away. That's a good thing, because that means this is not going to be nearly as hard of an equation to solve. Because now I'm left with x minus 1 is equal to 2x minus 4. So if I want to solve this, that's going to be a whole lot easier. I don't have to factor or anything like that or use the quadratic formula. I'm going to move my x's to the right. So I'm going to subtract x. And now I'm going to go over here. I'm going to have to come over here to work because I'm out of space here. That would be negative 1 is equal to x minus 4. And then if I want to solve for x, I could just add 4 to both sides. Yeah, come on. X equal 3. Yay. And so I think we get through those fast. Okay, so we'll do 11 and then we'll do 12. Let me write down which ones we did. We did 5, 10, and then we're going to do 11 and 12. And there is no 15 if you're listening to this and you asked for 15. I don't know where you got it. Okay, so number 11 looks like this. And this is one of those things that the key to noticing what to do is that these segments are all parallel to each other, those lines are. So since they're parallel, all you got to do is match them up and make a proportion. You could say 9 goes to 6 the way that x plus 4 goes to x. And then when you cross multiply, you get 9x equals 6 times x plus 4. So that would be 9x equal 6x plus 24. Subtract 6x from both sides. 3x is equal to 24. And that means if you divide both sides by 3, x is 8. Okay, so that was 11. That was asked for, I think, in the 9th grade class. And then we had 12 that we just had asked for. 12, I see something tricky about it. When I look at 12, here's what I kind of think is tricky about this one. First of all, they didn't tell us that we had parallel lines, did they? They look kind of parallel, but they didn't tell us that. And let's see, we have 16, 14, 4, and 3.5. Now the x that I'm missing is right here. Even if those lines were parallel, I couldn't use that parallel pieces thing, you know, where you have the two parallel lines and the side pieces are proportional to each other. I couldn't do that here because my x is not in the right spot. It's on like this base down here. It looks like these are similar. I know that if I separated these out, just looking at this, I kind of feel like there might be a piece of missing information here, but I don't know. I've got 6 on the small triangle. It's 16, 10, and 14, and on the big one, it is 20 is that whole side, and then this side would be 17.5, and then this would be x. Trying to see if I've got some kind of scale factor here. I don't know that I have enough information to know that these are that these are similar just because there's nothing marked. So here's the only thing I can do. I know this angle is congruent to this angle because they're the same angle. If I wanted to find the scale factor, I could say, well, what's 20 divided by 16? Because those sides match up. And the scale factor would be 1.25 there. Let me try the 17.5 divided by 14. I also get 1.25 there. So the reason that I know that these are similar and that I can do proportions is because that this and this have a scale factor of 1.25, and then this and this also have a scale factor of 1.25. That being said, if I know the scale factor is 1.25, I could either do a proportion. I could set it up like 16 goes to 20 the way that 10 goes to X. That's one way I could solve this. But if I know the scale factor is 1.25, couldn't I just multiply 10 times 1.25? That might be quicker. That would just be, what, 12.5? Let's just check it out to make sure, or just to show both ways, I guess. If I cross multiply, I'd get 16x is 200. So if I divide 200 by 16, I'm hoping it is 12.5. Is it? Yep, it is. So you can see that sometimes there's faster ways. If you know the scale factor, I could have just simply done that and I'd been done. I wouldn't have had to do the proportion. And there's quite a few I've noticed on one of these pages that worked out that way.